All right, so this is section 5.2, and we're going to talk about annuities, future values, which we've already discussed, but in a different way, and this concept of a sinking fund. So, first, we're going to define and calculate some ordinary annuities. We're going to find future values when we have annuities, and then we'll calculate sinking funds. All right, so an ordinary annuity is a sequence of payment that is made towards like a savings account or a loan. So just when you think of like monthly payments, that's what an ordinary annuity is. So the price is set for the payment amount. And so you're just going to make it every month or every 2 months, 3 months, 4 months, every year, whatever it is. But we call those ordinary annuities. So this is the formula for an ordinary annuity to find the future value. So PMT, that represents our payment, and that's per period. Most of the time we'll discuss monthly payments, but it could obviously be any period. Then we have the interest rate as R. The N represents the number of periods per year. Just to make a note, the number of payment periods and the number of compounding periods will match. So if it compounds 12 times a year, then we will make 12 payments a year, and so on. And then T represents the number of years. So this is the formula to find the future value when we are making ordinary payments or annuities. All right, so let's do an example of that. So investing in a money market that accrues 0.61% APR with payments of $500, and we're compounded quarterly for 3 years. Okay, so I just want to make sure I write down all the information I need. So my payment is $500. My rate is 0.0061 because it's 0.61%. My N, which is my compounded, I compound quarterly, so 4 times a year. And then my time, my T, is 3 for 3 years. All right, so then I can just plug everything into that formula. So I have 500. There we go. Times 1 plus my R over N, 0.0061 over 4, raised to the N times T, so 4 times 3 minus 1, all divided by 0.0061 divided by 4. Okay? So again, it's just filling in the necessary information, and it is not about, I'm not worried about your arithmetic aspect as I am just filling in the information. And that being said, at this point, just plug it in the calculator. There's no reason to try to simplify any. So we plug it in the calculator, and we find that if we made payments of $500 every 3 months for 3 years with this interest rate, we would have $6,050.58. Yeah. And you can kind of think, okay, does this answer make sense? Because it's an easy way to check yourself, and you don't have to be exact when you're checking, but you can kind of think, okay, well, if I'm making 500 payments quarterly, so 4 times a year times 3, that's 12. Well, that is $6,000, right? So I drew $50 worth of interest on what I paid in. So that answer does make sense. Okay, so that's just an easy way to check yourself, but the answer is $6,050.58. All right, so a sinking fund. So sinking funds is just a fund that money is set aside to pay off some kind of debt or to save for a purchase. You can kind of think of it as like if we were saving like a savings account. Companies do this when they know they're going to have to pay like a retirement or some kind of insurance settlement or that kind of thing, some kind of bond. They can set money aside make payments on the money that is set aside, let it draw interest, and then use that to pay off whatever settlement. And so it's just another example of an ordinary annuity. We're making payments into an account to see how much money we have after so long. Okay? So the sinking fund idea here is we have a future value in mind that we want to know, or that we want to get to. So what size payments do we need to get there? So we have this formula that PMT is equal to the future value times the rate divided by the number of periods, all divided by 1 plus R over N raised to the NT minus 1. All right, future value is the desired future value. So if we want to save $25,000, that would be our FV. Our APR is our rate, which is R. N is the compounding periods per year, and T is the number of years. Okay, so let's say that Brian is saving to buy a car, and he needs $3,000 for a down payment, and by making monthly payments into an account, 5% interest, all right, how much will Brian's payments need to be? All right, so let's look at this then. So we know that our desired future value is 3,000. Okay, our rate is 5% or 0.05. Our time is 2 years. Okay, one thing to pay attention to, like I mentioned earlier, we have monthly payments. We want to see what our monthly payment would be because that's a reasonable thing to do. So N will be 12. So our compounds, this will compound 12 times a year while we're making payments 12 times a year. Okay, if you're compounding 12 times a year but only making 4 payments, it gets tricky on the calculation, so we're not going to worry about that. All right, so we just plug it in. So we're trying to find PMT. So I have my future value of 3,000 times my rate divided by my periods, all divided by 1 plus. And you can tell these are all similar in their setup. It's just different derivations of the same formulas. Okay, so, and then I have 12 times 2 minus 1. All right. And so then I plug that in the calculator, and it tells me that my payments would need to be $119.11 a month. Okay, or roughly. I mean, you might have to make a little extra on a few cents, but that's 119.11. All right. And so if we wanted to do a quick check of that again, right? Well, I know that I'm going to make 2 payments, 2 years worth of payments times 12, all right, times 119.11. So then I can just check and see, well, does that answer make sense? Do I get to my desired future value? So 2 times 12 times 119.11 gets me to $2,858.64. Okay, so that answer is a little bit off as far as the size of payments we're going to make, but that also comes into because of the when the payments are made. But our answer does make sense. Okay. All right. So here are some practice problems for you. And we can, I'll give you the answer to these, and then you can try these on your own. So find the future value of the account with payments of $900 at 0.61% compounded monthly for 5 years. Okay, so we want to find the future value. And so that future value is $54,817.79. Okay, so we're making $900 monthly payments for 5 years. All right, and then find the amount of payments needed to accumulate $25,000 in an account that earns 9% compounded quarterly. So our payments are going to be quarterly. So every 3 months we're going to make these payments, and that is $1,539 $1,000,000.06. All right. And so that sums up our 5.2 on talking about payments and future values, ordinary annuities. So our last section will be 5.3. If you have any questions, please feel free to email me and let me know, and have a great rest of your day.